All right, class. Today we are going to talk about something you see every day, but maybe never thought about too deeply: how heat moves around. Imagine this. When you touch a hot cup of tea, your hand feels warm. Or when you drink cold soda, after some time it gets warm too. Why does this happen? It's because heat always likes to travel from hot things to cold things. Like how you would slide down a playground slide, always from high to low. Heat also slides from hot to cold. Now, some people think that if you know how much heat is in something, that's enough. But for engineers, we are not only interested in how much heat moves, but also how fast it moves. Think about your hot coffee. You don't just want to know how much heat it loses. You want to know how long until it becomes cold. That's where heat transfer comes in. Thermodynamics tells us about how much, but heat transfer tells us about how fast. Heat moves in three ways. First is conduction, like when you hold a metal spoon and it gets hot because heat moves through it. Second is convection, like when you feel warm air from a hairdryer because heat rides on the moving air. Third is radiation, like feeling the sun on your skin even though there's no air between you and the sun. Heat moves like invisible light waves. Every day, all three are happening around you, even inside your body. You cool down by losing heat to the air around you. But let's go back in history. Long ago, people thought heat was like an invisible liquid called caloric, and it flowed from hot to cold like pouring water from one cup to another. Later, smart people like James Joules discovered heat is really the energy from the crazy movement of tiny particles we can't see. So heat isn't a liquid, it's the energy from molecules moving, bumping, dancing around. In engineering, we use heat transfer to design many things: air conditioners, heaters, refrigerators, cars, even your computer. Heat transfer also tells us how to make homes warmer in winter and cooler in summer, and how thick your walls should be to save electricity. It even helps us decide how big to make heaters or coolers before a building is built. Let's talk about energy. Energy comes in many forms, like motion, electricity, chemical reactions, and heat. Heat is special because it moves only if there's a temperature difference. Like how water flows downhill, heat flows from hot to cold. If both sides are the same temperature, heat doesn't move at all. Just like a flat road with no slope doesn't let a ball roll. Another idea is something called specific heat. Imagine 2 buckets of water and metal. You need much more heat to make the water hot because water stores heat better. That's called high specific heat. Metals heat up quickly but cool quickly too because they store less heat. This is why hot water bottles stay warm longer than metal kettles. When we talk about heat transfer, sometimes we count it in terms of power, like watts, which means how much energy moves every second. Just like a faucet pours water per second, heat power tells us how many joules per second are moving. Let's make it fun. Suppose you were baking a potato. Engineers don't calculate heat for every bump on the potato. They imagine it like a perfect round ball of water. This simple guess saves time and still gives good answers about how long it takes to cook. Lastly, let's learn about the 3 ways heat moves. Conduction is like a row of kids pushing each other in line. The energy pushes along without anyone leaving their spot. Convection is when heat rides along moving fluids, like soup swirling in a pot. Radiation is special. Heat jumps straight through empty space, like feeling the heat of a campfire even if you're not touching it. Every day, all 3 are happening around you, even inside your body. You cool down by losing heat to the air around you. And the most important rule is this: heat never moves from cold to hot by itself, just like you'll never see a ball roll up a hill without someone pushing it. Engineers use this knowledge to design better machines, safer buildings, and more comfortable homes. That's it for today. Simple and fun, like telling a story. Next time you drink hot chocolate or turn on your fan, you'll know the science behind it.